Okay, so 5-4, factoring GCF, which then in turn we're going to go ahead and factor. Okay, what is the GCF? Does anybody know what the name of that is? Greatest common factor. What do they have in common? Okay, so here's our first polynomial. We just added and subtracted polynomials and multiplied polynomials, right? Factoring is kind of undoing multiplication of polynomials, correct? Kind of the opposite of what we did there. So first off, what I'm looking for is what numbers does 6, 10, and 14 have in common? Do they have any numbers in common? They have a 2. Do they have anything higher than a 2? No, 2 is the highest. If you needed to, ladies and gentlemen, you could prime factor. Notice I can't break down 5, 3, or 7, right? Since this is already prime factor. Notice you just find out what they have in common. They all have a 2, correct? That's basically what you probably learned the very first time doing this. But once again, I'm teaching you as you've never seen it before. Okay, what's y cubed? Y times y times y, isn't it? Y squared and a y. What do they all share? They share a y, don't they? So overall, they share an, as Tyler just, I believe, said, 2y. Correct? So, with that being the case, that's the greatest common factor. That's what they have in common. So, with that being the case, what's left over? I factored it out. That's kind of what we did in the 7-2, those examples that I worked with. Ryan and Haley and other ones. We factored out, remember? Okay, and so like when we factor out, that's like dividing out, correct? So 6 divided by 2 is 3, and that's notice what's left over, right? So I have a 3y squared, because notice 3 divided by y cubed divided by y is y squared. You'd have minus 5y here plus 7. Notice basically everything that's not circled is what's left over, right? Okay, basically that's the opposite of what we did last time. Agreed? Okay.
Really don't want to get too much into that because I think we can do a harder one. All right, what do we want to need?
Then we'll get to something else. Okay. So looking at this polynomial, this is another polynomial. What would they have in common? So I always look at the numbers first. 2, an 8, and a -6. What do they all have in common? They have a 2 in common. Does everybody understand the 2? Then I go to my next variable, which is m. Okay? What does m have in common? Because I have m to the 4th here, m cubed here, m squared here, so m squared is the least amount, correct? And what do they have in common with their n's? N squared as well, correct? So if I did 2 divided by 2, nothing's there. M to the 4th divided by m squared. I need an m squared here. Notice n squared divided by n squared is there. It's gone as well, so it's just an n squared. Are you there with me? Okay, if I pull a 2 from an 8, because once again it's 8 divided by 2, left over is a 4. If I pull m squared out of m cubed, I'm left with an m. If I pull an n squared out of n to the 4th, I'm left with a n squared. Any questions on how I got that? Once again, dividing, and when I divide the
like bases, right? I subtract their exponent, correct? Okay, negative 6 divided by 2 is negative 3. I pulled out all m squared, meaning he's completely gone, right? But how many n's are left over? N to the third. Okay. Any questions on those? I do want to do one more. What do these guys, what do those guys have in common? What'd you say? 2x. So after I pull out a 2x from 4x squared, 4 divided by 2 is 2. X squared divided by x is x. Now this is where a lot of people struggle. They're like, I pulled out everything. What's left over? 1, right? And that's why I always like to do the division. What's 2 divided by 2? 1. X divided by x, 1. And why it's still 1. If you lost that, you just lost a placeholder. Would you guys agree that 2x times 2x is different than 2x times 2x minus 1? Because once again, that lost its placeholder, which would eliminate that term, correct? So always make sure you have enough that you can make sure you have enough terms that okay? Any questions on those? All right. Next one. Okay, I'm going to write something here. Okay, this one people struggle with seeing a little bit more. But what do they have in common? They have x minus 3's, don't they? Does everybody see that? Because this is 2x times, just like it was on our previous example. There's more than one thing, right? There's 3 things here. Okay, same thing here. There's 3 items. 2 times x minus 3, right? Sometimes I like to show people, just for example, if I had 2xa minus a, what do those guys have in common? They have the a. You can see that better, can't you? Could you understand that this is representing an a in a way, right? So basically, we're going to pull out the x minus 3. What's left over? If I pull x minus 3 out of here, what's left over? 2x. If I pull x minus 3 out of this guy, what's left over? Negative 1. Okay. Any questions there? You guys did some of this last time too, right? Okay, what about this one? What do they have in common? They have an x minus 4 in common, correct? Okay. So they have an x minus 4 in common. So if I pull an x minus 4 out of x minus 4 squared, what's left over? X minus 4, right? What are these guys? What am I pulling out again? The x minus the 4, what's left over? And then notice, guys, can I simplify the inside if I needed to? What would that simplify down to be? And then this becomes 3x minus that. Okay. Any questions on basic factoring? Pulling out GCFs, right? That's basically 5-4 in a nutshell. Pretty simple. Okay. All right. So, really quickly, let's start here. Okay, what did you guys do to do this yesterday or last time to go ahead and simplify this? You guys did the area model, or you did FOIL, or whatever it might be, correct? You guys agree? I'm just going to bust through with FOIL. Then I get plus 3x minus 4x minus 12. So, if you'll understand, okay, let's talk about stuff really quick though. Where did this x squared come from? Basically our front terms, right? You guys agree with that? Okay, where did the negative 1 come from? It came from the 3 and the 4, but where the 3 and the 4 are what we consider factors of negative 12. Would you guys agree? So they were factors of negative 12. Notice here's all the factors of negative 12. 1 and 12, 2 and 6, 3 and 4. But 3 and 4 is the only pair that subtract to get negative 1. How do I know I needed to subtract these items? Well, first off, because it told us to, but in the end, the reason why is one's negative and one's positive. And I know that because this is a negative 12, right? How do I get to a negative 12? One of them has to be negative, one of them has to be positive, correct? You guys agree with me? What if this was a positive 12? What does that tell us? Both are positive or both are negative. Would you guys agree with that? Okay? So, but this is the one that gets me there. 4 minus 3 does get me to be 1. Now I just have to make sure which one gets me the negative 1, which this would be the positive, that would be negative, correct? And once again, why am I doing so? Because this is how I teach the factor, okay? My way of factoring a trinomial works whether your first coefficient is a 1 or a 5. Now, hopefully you start to see them quicker when they are 1s, that they're just basically the factors of this guy that adds to this, right? Does that make sense? But if it's not, for example, I'm going to show you what I would do here, okay? Well, we'll do this one and then we'll go on. So what I do is I call it my rainbow method, which is still factoring by grouping. What I do is I take the front coefficient and I multiply it to the back coefficient. Okay? And the reason why I do that is because that's what number is the largest possible that I can get, correct? Because if you guys think about this, what if this was a 2? What's the largest number that I could really get out of multiplying those two together? 24, right? Does everybody agree with me on that? But he's a 1. Okay? So once again, we just did our factors. 1 and 12, 2 and 6, 3 and 4. Now, why am I choosing 3 and 4? Because we are looking for factors that add or subtract to be negative 1. Okay, if this is a minus, I'm going to subtract these two. If it is a plus, I'm going to add these two. Does that make sense? So once again, it's this pair because that does get me to be 1. But notice I need to be negative 1, so he needs to be negative and he needs to be positive. So I'm going to rewrite this term. Did I change the value of what I did there from here to here? Did I change the value of the expression? Is it still an equivalent expression, just looks different? Because negative 4 plus 3 is still negative 1, correct? Voucher, I love the voucher. I miss her already. I mean, have vouch. Oh, she was such a great lady. Is, she still is. Not was.
Every once in a
She's
while.
still here.
Every once in a while, I do remind myself,
Well, go say hi. Okay. So what I'm doing now is I'm going to be pulling out what they have in common. Okay. What is the GCF of the front two terms? X squared and negative 4x. What do they share? An x. So Ben, what's left over? Good. Okay, Abby, what do these guys share? 3x minus what? They share a 3, don't they? What's left over, Abby? Oh, look at that. Ladies and gentlemen, if these aren't the same, you did something wrong. Okay? Because notice, we just did factor by grouping just previously on this example. Notice we did it right here, didn't we? We pulled out what they have in common. Okay? Do I still have something in common right here? What do they have in common? The x minus 4. What's left over? If I pull an x minus 4 out of here, isn't x left over? If I pull the x minus 4 out of here, what's left over here? 3. Now, is there different ways to teach factoring? How many of you guys learned that way that I just showed? Awesome. How many of you guys did not learn that way? Which is completely fine. Okay? If you know how to factor, I'm not going to try. I'm teaching you a way that works every single time. I'm not saying the way your teacher taught you in the past is horrible or wrong. I used to get told how to factor by guessing. That's how I got told. You guys want to see how factor by guessing works? You guys ready? All right, here we go. Let me see. All right, here we go. This one's not too bad. This is how I got taught. So they're like, draw your hippo butts. And they look like a hippo butt. Morimoto's all saying, right? No, you guys haven't watched that show? Okay, how do I get to 2x squared, ladies and gentlemen? Anyone? Bueller. I need an x and I need a 2x, don't I? This is an easy one. How do I get to a 5? 2 and 5? 2 and 3? Those multiply to get me to 5? 5 and 1's the only one we got, right? So where does the 5 and where does the 1 go? So this is really how I was taught to factor. So then I'm like, oh, I need 11, so I got to have a 2 times 5, so the 5 has to go there and the 1 has to go there. That's really how I was taught. Okay, and I actually got pretty good at it because that's the way I was taught, right? Any method that you get taught, you get pretty good at it because that's how you learn it, right? But let me show you really quick here. What if I had 12x squared minus 4, oh, it's not be 12, let's do it. I don't know, we'll do that, yeah. All right, let's look at this guy. Factor by grouping. Not factor by grouping, but, sorry, I can't even talk to you guys. By guess and check. How do we get to 12? What's our option? 1 and 12, 2 and 6, 3 and 4. So I have all those different options, right? I hated it. After I learned this new method, I'm like, why did my teacher screw me over and teach me to guess and check? Because what's the factors of 4? 1 and 4 are 2 and 2, right? So then I had to substitute things in to see if it would work, and then I had to run FOIL to see if it worked. That method stuff. Okay? So like I said, I'm just not sure on how people have taught you, so I'm going to teach you a way that works every single time. Okay? We'll do this one more time. And it should come out to be this one right here. Okay? 2 times 5, what do we get? 10. Always take your front number to your back number. So I get 10. Factors of 10 are 1 and 10, 2 and 5. Can 3 go? Can 4 go? You see how 5's on the other side? See how I asked every number until it wrapped around? That shows I look for every single factor. Okay? Now, this is a positive 10. So what am I going to do to these numbers? I'm going to add them or subtract them. I'm going to add them. Okay? 1 plus 10 is 11. 2 plus 5 is 7. Which pair am I going to use? Notice I'm trying to get to 11. Thank you. You guys are awesome today. I must be that horrible of a teacher today. So I'm going to rewrite it. Did I change the value of my expression? Did you check it? Did I change the value? Does x plus 10x still equal 11x? So did I change the value of it? No. Okay. Then I go for factor by grouping. I group the front two. I group the back two. And I say, what do I have in common? Okay. Eva, what does the front two have in common? So if I pull out an x, what's left over? Plus 1. Remember, if I factor something all the way out, there's always a 1 there, right? Does that make sense? Everybody there would agree with us? Okay. Chandra, what do these guys have? 10x and 5. 5. Can you tell me what's left over? 2x plus 1. Right? Did I change the expression again? No, I just made it look different, correct? Okay. Now, I'm not factoring by grouping or just kind of what pulling out a GCF. That's what I'm doing right here. What do these guys share? These guys share the 2x plus 1, correct? So Hiram, what's left over if I pull out 2x plus 1? What's left over from this guy? From the left side, this guy. X. How about these guys? There you go. Is that the same way that I got my answer previously? Sure. Now, was the other way quicker? I agree, it probably was. But that was because it was nice, because 2 really only has 2 factors, 1 and 2. 5 has only 1 factor, 1 and 5, right? Does that make sense? If it was 12 or something that's horrible, 24 or 32, good luck. You know what I mean? If you were factoring by guessing, there's so many options there. And it just wasn't very easy. Okay? So the way I'm showing you would work every single. Any questions there? All right. How many of you guys saw this guy that after you multiplied, you got something like such? 4x squared minus 9. Some of your homework problems last night were like that, correct? After you multiplied it through. Okay? Does anybody know what this is called, by the way? It has a special name to it. No, no, no. Okay. In the past, or you should have seen this somewhere, it's called a difference of squares. And the reason being is, what number is 4 that's squared? Isn't that 2 being squared, correct? What number is x squared being squared to get to x squared? What number is being squared to get to x squared? X. What number is being squared to get to 9? 3. Hence why it's called a difference of squares, because there's 2 numbers that are perfect squares. Okay? Now, I could rewrite this to be such. Did I change the value of my expression by putting that term in there? Because what's 0 times anything? Still 0, so nothing has changed, correct? All right. So with that being said, once again, I'm going to factor, and then you're going to see what sum comes out in the end. Okay? So I'm going to go 4 times negative 9. Negative 36. I'm going to do my factors with 36. 1, 36. 2, 18. 3, 12. 4, 9. Can 5 go into 36? 6 and 6. See how it wraps around? That tells me I'm done. You notice how I asked every single number until it wrapped around. Because as soon as it wraps around, it shows that every single, you found every term. Okay? I would highly suggest you do so. Now, Once again, this is a negative 36, so I'm looking for a pair that subtract to be what number? No, that subtracts to be 0. Who's my pair that subtracts to be 0? Does everybody agree that it's this guy right here? Okay. Once again, from here to here, from this stage to this stage, are they different? Yes. But are they different expressions? No, because once again, 6x minus 6x is still 0. I didn't change the expression, the value of it, I just changed what it looked like. Correct? All right. So then I group the front two. Zach, what do the front two have in common? They do have a 2x. Can you tell me what's left over? They do have an x plus 3, but 2x plus 3, okay? Does everybody understand how Zach found that? Walker, what does the next two have in common? Negative 6x minus 9? They do have a negative 3. And I'll be honest, guys, if your third term or your first term is ever negative, pull that out. Okay? If your third term or your first term is negative, always pull out a negative, okay? So I'm going to pull out the negative 3 just like Walker said. What's left over, Walker? Would it be minus?
No.
Because you pulled the minus out, right? Does everybody understand where Walker got that from? Okay, and last but not least, what are we pulling out now, Connor? We're pulling out what they have in common, which is the 2x plus 3. What's left over, Connor? Okay, does anybody remember what the name of these two are called? These are called conjugate pairs. You guys see how they're the same numbers. They both have 2x and they both have 3, don't they? That's a conjugate pair. The only difference is one is positive and one is minus. Anytime I multiply conjugate pairs, I will get a difference of squares. Notice, and the 4x squared minus 9 was the difference of squares, wasn't it? Right? Okay. Any questions there? All right. Okay, if you can't read that, that's x squared plus 7xy plus 12y squared. Okay, let's just kind of think about it the way I was taught. Once again, this is kind of the guess and check method, okay? Just so we can get an idea of what's going to happen. How do I get to an x squared? I need an x here and an x here. Do you guys agree with that? How do I get to a y squared but still have the terms x, y? I need a y squared and a y, right? Y times y would give me a y squared, but notice I'll have an xy and an xy. Do you guys agree with me on that? You see what I mean by that? Okay. So basically, I could just go right here. Anytime this number is really 1, I can do this very quickly. What's the factors of positive 12 that give me the 7? 1 and 12 does not get me there yet, but 2 and 6, does that get me there yet? How about 3 and 4? Yeah. So this is actually called quick factoring, is whenever you have a leading coefficient of 1, just jump to the back number and look for its factors that add or subtract to be the middle number. Does that make sense? We could do that very quickly. Could I still do it my other method? Sure. Once again, still, 1 times 12 is still 12. Factors of 12 that give me the 7 is 3 and 4, just like I've already brought up. So I'm going to rewrite it. X squared plus 3xy plus 4xy plus 12y squared. Did I change the value of the expression from there to there? Yes, but it's still equivalent, correct? Still an equivalent expression, meaning if I simplified it, I would get the same result, right? Okay, Chloe, what does the front guys have in common? They both have an x. What would be left over, Chloe? Good. Okay. Tanner. Where's the thing? Tanner's your last name. People with 2 first names. Okay, Thane. What does the back guys have in common? They do have a 4, that's it? 4y. What's left over, Tanner, if I pull that out? I mean, Thane. Good. Once again, they're the same, which they should be, correct? Eva, what do I pull out here? Pull out this full binomial. So I have x plus 3y, and as you said, what's left over? Okay. Once again, is there sometimes quicker methods? Yes. But I'm showing you a method that works every single time, no matter what it is. Okay? Is everybody good with me there? Understanding how we're getting that? Okay. You guys ready for another one that's a little bit more intense? Is that something we can factor? Yes, it is. What's some 2 ways I could do this? One, I could just distribute through and get everything and make it just a trinomial. Okay? You guys get what I'm saying by that? Meaning, this would be x squared plus 10x plus 25 minus 3x minus 15 minus 8. I did this to be him, this. Is everybody with me on that? So I could do that, and I get x squared plus 7x minus 8. And I could just factor him in general. Okay? Does everybody see what I just did there? We could do a quick factoring, because once again, our leading coefficient's a 1 here, isn't it? What's the factors of 8 that get us to 7? Alex? 8 and 1, who gets the negative, who gets the positive? -1, +8. So that's what it should be factored to be, right? Okay, but I could do this a different method as well. Okay, I'm going to scroll down. This in the end is what it should look like. So I'm going to come down here though. Once again, it was x plus 5 squared minus 3 times x plus 5 minus 18. There's a minus 5 in here? Okay. If I'm wrong, I'm wrong. Okay. Can you guys kind of see how this is something like, if I say u is x plus 5, can you guys see how this is u squared minus 3u minus 18? I just called u what this guy is and this guy. You guys see how I could factor him? Okay. Greg, what's the factors of 18 that get me to be 3? If you don't know, 6 and -6 and 3, because that would add to give me -3, right? I can wait, is that correct?
Yeah,
Correct. Correct. Okay, so as he just said, this is u minus 6, u minus 3, correct, Greg? Or plus 3. Thank you. Would you guys agree with that? But who's our u? Because do I want it left as these? Is that what we had, was u's up in our original? So who's our u, though? What can I replace with u? X plus 5. Everybody see that? See how I replace the u with what u equal? Okay. And then notice we could simplify. What's x plus 5 minus 6? X plus 5 plus 3. And that's what I originally had in there. So it all depends on what your preference is. Notice, basically, I just looked right here and said, oh, that's something squared minus 3 times that something minus 18. That's still in the same form that we've been doing. Something squared minus 3 times that minus 18. We're still factoring a trinomial, are we not? 3 different terms. This is 1 term, 2 terms, 3 terms. Right? That's all I did was factor that out. Okay? Just seeing if I hit pretty much everything. Actually, let's let you guys try to factor one by yourself. Okay, go ahead and factor that one on your own. Give it a shot. Does it have to be my method? You can do any factoring method as long as you know what's up. Okay? I'm going to push pause. Mallory, do it, right? So she's going to help me guide. What did you do, Mallory? 4 and 6, what did you get? 24. So we're looking for the factors of 24. It shouldn't have factored. Anybody get that didn't factor? Good, because it didn't factor. Let's make this a negative 6. And then we'll just do it. Hey. I'm sorry I'm a nincompoop. But you got it the way I thought it was. We're still good. So negative 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which and is 5 no? Nope, so hence 1 to get it wrapped around. Does everybody see the wraparound thing? Hear what I'm talking about? How I asked every number until it wrapped around? Things like no. So watch. Did I ask every number? Did 1 go? Did 2 go? Did 3 go? Did 4 go? Did 5 go? 5 doesn't, which is okay, but who's the next number? See how he's on the other side? So when it wraps around, then I know I've asked every factor. Does that make sense what I'm going for there? Okay, Mallory, which 2 did you use? 3 and negative 8. Great job, right there. So she did negative 8 plus 3x. Right there. Me personally, if I can, I always like to do the negative in the second place than the third. That's me personally. Does it have to be? Would you get the same result? Sure. What do those guys share, Mal? A little bit higher. There you go. 4 and an x, and I'm left with x minus 2. Ashley, what do these guys share? What's left over? So I have x minus 2, that's what's going to come out. What's left over, though? There we go. Okay? Any questions? I apologize at the beginning by giving you a positive instead of a negative. I'm a thinker. You guys need more? You feel good? Where are you at? Hiram? You're not looking at me, so are you good? Anyone down this aisle? Abigail? You want a leg wrestle? I had a leg wrestle with a girl that was on drill team the other day. You know, almost beat me. Like I had her, but then my legs started getting tired because she could do 8 hours of sweat and I couldn't flip her. You just need to get more stretchy. Anyway, I'm just trying to get her to smile. Anybody down this row? Britt, anybody down this row? Because really that's it. I'm just going to see if I have any more that I really need to look at. That I've given you all examples about. Okay, that's it. So your homework is which one am I doing? This, by the way, is on page 442. And yes, Brittany, that's back in the review area. If we had time, I'd go into those more. But you guys are always welcome to go back into the sections itself, right? And do a more practice problem. Because remember, this is the minimum requirement, correct? This is roughly about 8 problems, and this is roughly about 8 problems, so you have 16 total problems to do. That might not be sufficient enough for your practice. Could it be? Sure. But some other people might need more practice, so you could go back into the sections and review those, correct? Anybody have a question on what it is? Just a reminder, on Thursday will be our last unit for this test, right? Then we'll be going on to our test, which will be on Monday. Okay? And then after that, that's our last. Nope, I think we have one more test before the quarter. And then in the second quarter, though, we only have 2 tests total. So this quarter we get 4, and the next quarter we have 2 plus the final. Yeah. 7.1, 7.2. So basically what it will be is the 7.1, 7.2, 5.1, 5.2, 5.4, 5.5, 5.6, and 5.8. It will be all those sections. So once again, you could get any of those practice problems by working on those extra within the textbook or back in the review section, whatever it might be. I would highly suggest you choose the odds. Once again, why? Make sure you're doing it correct, right? Hopefully you guys are still checking to see if you're doing your work right, right? Because you have a tool to use it to make sure, because if not, if you get it wrong, then you should look back and say, hey, this is what's that, okay? All right, guys, thank you so much.